So it's time for me to upgrade the router here in my home lab. And I guess the logical choice for hardware for that was my Mono Gateway development kit. So for those of you that don't follow Tomasz on YouTube, he's been spending years building this great 10 gigabit class ARM-based router and documenting his whole process on YouTube. So he did a pre-order for the first 1,000 developer kits. I was pre-order number 59, and so I have my dev kit right here. So this guy is based on an actual, like, real routing chip, like a home small business routing chip. So this is an NXP Layerscape. It's got two 10 gig interfaces, three 1 gig interfaces, and the Layerscape has hardware packet offloading. So between the CPU and the network cards, there's a hardware packet engine that can do routing, state tracking, that kind of stuff, so that this can actually hit 10 gig throughput on the basic ARM CPU. And that makes it incredibly efficient and an excellent choice for me for this project. And through a combination of NXP's API and Tomasz's work, this all works entirely transparently on Linux. So on Linux I can do IP commands, IP interface, IP route, that kind of stuff. I can do nftables firewall. All of that gets pushed down into the hardware automatically with hardware offload features on Linux. So that makes this a great platform for me because you guys can follow it using just plain Debian on a mini PC, whereas I have this fancier hardware. So then I guess the big choice is what operating system am I going to run on this? So this came with OpenWRT. You guys know I hate OpenWRT. The logical choice for me would be OPNsense. Now I've used OPNsense now for years. Since before OPNsense existed, I used pfSense. But OPNsense is an excellent firewall if you're going to log in and configure it through the web UI. They're fundamentally based around a web UI where you log in, you edit settings, it applies the settings, it manages all the backends, that kind of stuff. And for most people, that is what they need. But I am not most people, am I? So of course I'm doing it the hard way, right? So I could run OpenWRT, except I hate that. I could run OPNsense, which has really great support on the gateway, and is really great in general. But again, I don't really want a web UI-based solution. I want to do something that I can automate from Ansible, from Netbox, that sort of thing. So I could do Vios, but Vios is basically trying to give you like a Cisco-style CLI, and I hate the Cisco CLI. So why would I want that? And so then I'm like, why don't I just use Debian? So this, one of the three, I guess, officially supported operating systems for this thing is Debian. So we have Armbian built for this, I guess Debian and Ubuntu. OpenWRT and OpenSense are the official OSs for this. So I can just pull up Debian and build my own router, right? And that all sounds great in theory until I remember I got a lot of routing to do. So just getting a LAN and a WAN set up means I have to listen for DHCP on WAN, have to hand out DHCP on LAN, I gotta do DHCP v6 prefix delegation, I gotta point those interfaces down to my LAN interface from the delegated prefix, I gotta do router advertisements on LAN, I gotta do DNS. It's just, it seems like a lot of work. So I'm trying to figure out today how I can build a fully declarative router here so that Ansible can push declarative configs to this thing. This thing can do all of the day-to-day tasks of querying DHCP, DNS, that kind of stuff. So that's what I'm building in this video using Linux. I must interject. What he's referring to as Linux is in fact systemd/Linux, or as I've taken to calling it, systemd plus Linux. Linux is in fact just a component in a complete systemd system, including all of the core services like systemd init, journald, networkd, resolved, udevd, lognd, and more that build out a complete systemd system. At this point, I was interrupted by my wizard assistant who needed some neck rubs before reminding me to tell you guys to learn Python using boot.dev. Boot.dev is a site that helps teach you programming and other tech topics in an easy to follow way. So the whole premise of this video is I'm switching from web UI like user interface based platforms to declarative config style platforms so that I can automate them in the future. And if you're in network engineering, one of the big industry trends now that's not a bunch of AI slop is actual real automation. And a lot of that's done using Python. So boot.dev has a full Python course which you can access entirely for free if you just want to read it and see what it's like. But subscribing gives you access to all of the gamifying features, including typing your code into their platform and executing it to check that it's right, which is pretty cool. Use my code APPLEARD to get 25% off or scan the QR code here. That's 16 euros a month if you subscribe for a year, or whatever that is in dollars. So click this link here. Now, back to the video. So I guess I better give myself some space for a big drawing over here. Okay, so routers. Today I'm going to be setting up something relatively basic, mostly as a proof of concept that these ideas work and they can be expanded to bigger systems. So I'm going to have a router, it's my mono gateway. I'm going to have a WAN that's connected to my ISP. In this case I'm simulating that because I'm not taking down my real network until this all works, but the idea is the same. So on the WAN side I have to do DHCP v4, DHCP v6, so that's how I get my addresses and prefixes assigned. Then down here I have a LAN interfaces, so I guess we'll call them LAN 1, 2, 3, I don't know. And on each of these I have to do DHCP v4 serving clients, I have to do router advertisements serving v6, I have to add routes between them, I have to advertise different prefixes, etc. So that's, I guess, the basic job of a router. So doing addressing, doing routing. Additionally, we'll say we're doing DNS here as well, providing DNS downstream. That kind of gets me the bare minimum of having a functioning router. I also need to do VLANs too, so we'll say any of these interfaces could be a VLAN, and we got to figure out how to set that up. So in case you didn't notice in my intro, I'm using systemd to do this today. Now I know many of you probably didn't know that systemd is a router, but systemd is everything these days. So systemd network D is fully capable of doing everything I had mentioned here except DNS, but resolved can do the DNS part, so that gives us a fully functional router using only systemd and NF tables. Oh yeah, I'm using NF tables for the firewall, by the way. So we're just going to write NF tables rules in a conf file, and that's going to be it. So the reason I'm doing it this way is because it is a declarative. So the guys that are all about NICs these days will tell you that declarative is the future. Basically what that means is we write a configuration file using some well-defined syntax that says what we would like the state of the system to be. So in this case, my conf files are my NF tables conf, that's a list of all of the firewall rules, and my systemd conf, so that would be a list of all of the interfaces, what hardware interfaces they're bound to, what they're named, etc., and a list of all the networks. So networks get applied to an interface, and so I have to configure those separately. And so I'm defining things like where do they get their addressing from? Do they get it from DHCP prefix discovery on another interface? Do they have static subnets, etc.? How do I hand out addresses? What configuration do I have for options? All of that goes in the conf files, which are declared. So the point of doing it declaratively, instead of with a web UI like OpenSense, is that I can then manage this through something like Ansible. So I can put my desired interface states, IP ranges, that kind of stuff in like Netbox, the database. When the database changes, it can hook on to Ansible. Ansible can generate new configs using templates, resolving templates, and push that to the router. And so this means I can scale up to an infinite number of routers. Ansible can generate configs and push them. But because the config is declarative and systemd is responsible for implementing the config, Ansible doesn't have to go into bare Linux commands. The system will reboot cleanly and come up fine even with Ansible not talking to it, that kind of stuff. So systemd network D is responsible for reading the declarative configs and implementing them, doing the day-to-day tasks like DHCP requests, DHCP serving, router advertisements, the sort of real-time stuff, whereas we're generating the high-level what the network should be config from Ansible. Now in this video I'm not doing the Ansible part, I'm just writing these configs by hand because I really like to know what the configs look like before I try to automate it. So for me, setting this router up with a couple of subnets is a way of learning how systemd network D expects me to work so that I can automate it with Ansible next. Okay, so I'm set up here with my mono gateway. I just had to get set up with enough networking that I could log in over SSH. So for me, I did that through the serial console, but if you have a mini PC, you'd use like HDMI, keyboard, mouse, that kind of stuff. So I'm connected in over Ethernet, and my first goal is to set up this first Ethernet port here as a dedicated like backup connection. So I've got 5 ports here, 2 of them are 10 gig. Realistically, one of these 1 gig ports is going to go to my router, or not my router, my cable modem. I'm not getting 10 gig from the cable modem, so 1 gig is perfectly fine. One of these 10 gig ports is going to go to my MikroTik switch, and the other 3 ports are probably not going to do a whole lot for me. So I'm going to have all the VLANs going over 1 port. I'm going to have WAN on another port. I could move it over to the 10 gig too if I had a 10 gig or 2.5 gig cable modem, but basically I'm dedicating 1 extra port to be this backup. I want this backup to broadcast a IPv6 ULA so that if I just plug a computer into this port, it'll always show up over multicast DNS at gateway.local. That way I can always log in and configure it No matter what happens to the rest of the network, this one port does not depend on anything else. So here we go. It's my first file. It's called 06backup.network. So in this case, I'm matching on an interface named eth1. In that network, I'm going to accept arrays just because in case I'm plugged into LAN or something here. I'm going to send arrays. I'm going to do multicast DNS. So the way that this kind of works is we start with a match section. This defines what interfaces could get bound to this network. Then we have a network section that defines like what options this network interface supports. And then some of those have additional information. So we can add an IPv6 prefix. So I just generated a ULA randomly. And then I say assign so we can self-assign. I can add as many of these as I want if I want to advertise multiple prefixes. Same with IPv6 send array. So by enabling send array, then we have a bunch of options here. I can set up the arrays. In this case, I'm trying to advertise myself over MDNS in a way that anyone can just plug into eth1 and get a valid address and SSH in. So you may have noticed already this is kind of config heavy. There's just an absolute ton of features supported by systemd, networkd, and that's why I'll point you to the official docs, systemd.network and systemd.netdev, the man pages for that. Also, I'm going to have all my example configs for this full router either on my blog or on GitHub, link down below for that, depending on how complex they are. I may put them in either place. But basically, this is a file similar to like an ini, where we have a group in brackets that contains options and values. This is the same format systemd uses across the entirety of systemd. So it inherits all of the wild configuration complexity systemd has. Also the fact that files get read from etc, run, user local lib, and user lib. It then sorts them by name. That's why I started with a 06. All the default configs from distros are supposed to start with 70 and up. Everything auto-generated also is supposed to start from 70 and up. So if you use low-numbered configs, start with a low number, they'll sort so that it'll apply them first. Essentially, the way that the networking works in this case is that each network can be matched to one or more things. So we could have an interface called like 99 default or something, which just says enable DHCP client, enable accept array. Most distros ship with something like that already. So then if they don't match anything, they just apply to any interface that hasn't been configured yet, they get configured with that option. So by setting a lower number, we're creating a more specific config for some more specific option. In this case, I've chosen to use 0 for the backup, 10 for WAN, 20 for my tunnel interfaces, which are part of my ISP ASN setup, and 30 for my LAN interfaces. That's just sort of my naming convention. You can match on things like MAC address, physical MAC address, which is the hardware-bound MAC address name. So if you don't want to use you don't have to use the new sort of Linux naming, so like ENP5S0 or something for PCI devices. I know that trips people up a lot. You can match directly on MAC address if you want to do that. In my case, the Mono Gateway guarantees that the ports are numbered 1, 2, 0, 3, 4. They're aware that that's wrong and they're going to fix it, but they're guaranteed, so I can rely on naming them ETH1, ETH2, ETH3. But for most of you guys, you'd probably be picking on MAC addresses or the topology addresses, however you've got your hardware set up.
One eternity later.
So I spent way too long struggling with my ISP provided router here. So this is going to replace my ISP router. I'm going to put the ISP router in bridge mode eventually. I do know it supports DHCP prefix delegation, and I've tested with it before with MikroTik, and it was a huge pain in the ass to get it to work right. So I've got a cable going directly to port 1 because that seems to work. It's doing some sort of weird MAC binding because sometimes it works, sometimes it doesn't, but it's working today. So that's good. So now I got this cable here going from ETH2 to the ISP provided router. So this is my WAN. This is not VLAN tagged, but I guess it could be. I got this cable on ETH0. This has nothing natively. Everything is VLAN tagged, so I got to set that up. I currently have one LAN set up here, just with prefix ID 2, and I got that connected to some VMs back in the closet that are acting as clients. So I can route across this. These are both gigabit. I can route across it at gigabit just fine. Firewall and that. First though, let's talk about how I got these interfaces set up, handing out DHCP, doing v4 NAT, and then I'll get into the firewall a little bit later. Okay, so here's the files I got now. So I got the backup network, which I already mentioned. I have a new network which just exists to add VLAN children, and I got my WAN and I got my LAN. So in networkd, a .network file applies to an interface and configures it. So that also, for some reason, configures the child interfaces if you have VLAN children, Mac VLAN children, other sort of child type interfaces. They actually have their own config file as well, a netdev. But if they're a parented interface, they have to be brought up by their parent. So that's a little bit of an organizational quirk, I guess. So even though I'm not using ETH0 plain, I still have to write an ETH0 config so that it can say that all of these VLANs are children of ETH0. Sounds pretty simple. It matches an Ethernet interface named ETH0. You could also go by MAC address here if you want to do MAC addresses, things like that. And then I'm just not accepting any addresses on this interface and purely setting up the VLAN children. And you can do more here. You can do VLAN equals ETH0.21, etc. This is a name, so I chose to name it ETH0.20 is my naming convention, but you could also call it like VLAN 21 or LAN 21 or whatever you want to call the interface. You put that name here. And that points over at the netdev. So the netdev creates a network device. In this case, it's creating a network device named VLAN 0.20, which is a type VLAN of ID 20. So I need one of these netdev files for each VLAN, which creates the virtual interface. And then once this interface is up, I can assign addresses to it with a normal network again. So here's the network. In this case, it's looking for ETH0.20 and configuring it. So I just have set up a v4 subnet, so 10.10.20.1. I have a DHCP server, so I have 100 addresses in the pool, starting at 100, so that would be 10.10.20.100 through 199 and 200, something like that. I'm also sending router advertisements, so we're not sending managed. We're sending lifetime of 1800, so that's 30 minutes, I think. And you can send as many prefixes as you want. You can set them via prefix delegation. So in this case, I'm taking subnet 2 from upstream interface ETH2. You can token if you want, which means I want to pick the first address. I could not do that and let it do EUI64. I have options here. Again, I can do a static prefix, so I can say I want to do ULA, I want to do a GUA. You can add as many of these as you want to add multiple prefixes on this interface. And all of this just works really well. So another quirk I found of networkd is it does actually fill in default settings quite well almost all the time. So one of those is DHCP prefix delegation. So if you have an interface that says use delegated prefix from a different interface, the parent interface has to request the prefix. And it will do that basically automatically and configure pretty good default settings. So I had to configure some special settings here because my router is stupid. But if your router follows the RFCs, which a lot of them don't, let's be honest, it should just work out of the box. So I should be able to say on my LAN, request a prefix from ETH2 subnet ID hex 2, and it should just work. So here's what my WAN looks like, by the way. So I'm asking for DHCP v4. I said DHCP is yes, which actually means v4 and v6. Actually, that's a typo. It should say both. And also accept RA. So RA is how we get the route advertisement, because DHCP v6 doesn't send us routes. I can send the delegation hint. I can force PD. Use address actually means to not request an address at all. So if we say use address as no, it doesn't even bother requesting it. Some services like that, I don't know. This is what I got that worked pretty well. So with this working then, I went over to my Proxmox system, I spun up a few VMs, connected them to my VLAN 20 here, and let's see how they work. And so over here on user test, I can run IPA, and I can see I got some addresses, so I got the GUA, the ULA, and the v4 address, so 10.10.20.150 looks like DHCP assigned this time. And I can ping 9.9.9.9, looks like that works fine. And I can ping 2620 FE. Looks like that works fine too. So everything's now going through this box happily. One of the side effects of using the Mono Gateway 2 is that their hardware offload works for all of this stuff. So you probably won't have a Mono Gateway. They only made 1,000 of them. And he's struggling with RAM prices to make more, to even come up with a business plan that makes sense to make more. But if I do an iPerf test loading these things at full gigabit, we won't even see it on the CPU load. Okay, so we're doing gigabit here, looks pretty happy. Meanwhile over here on the gateway, it looks like we're using 2.6% CPU. 0.3% CPU. We are using no CPU here. So now, using only systemd, I have met the requirements for a router. So I'm doing routing. In addition to doing routing, I'm doing DHCP, v4, v6, prefix delegation, basically everything involved in the routing part of routing, and NAT too. When most of you guys, though, think of like a home or small business router, you probably think of like a firewall router too. So I guess I need a firewall. And here I'm not using networkd for that, because networkd doesn't really do firewall. So I'm just using nftables.conf. So this is writing nftables rules directly in their script syntax. This is already a super declarative environment. It reloads the script on command. So this is what I'm going to do for my firewall rules, and they're going to get generated by Ansible later, but I want to learn how to do them manually now. So here's my nftables.conf. So it starts with the shebang to call nft. So that means we can call this like a script. And then we flush the rule set and rebuild it every time, so we don't have any lingering rules hanging out there. Now, nftables is actually sort of a full-on scripting language because we can define variables. So I've defined here my WAN and my LAN 20 interfaces. We could define more than this if we wanted. So I could say like define LAN ranges equals 1. So if I want to do a range or something like that, I can define them up here in the local section. Next we have the filter. Below the filter we have IPv4 NAT. So this is IPNAT, not INET-NAT, so it's IPv4 specifically. And so I guess we'll talk about filter first. So in filter we have chains. So we have input, we have forward, and we have output. This might not be super familiar to you if you've never dealt with NetFilter before. NetFilter essentially has 5 stages that packets go through, that packets can go through. They don't hit all 5. So first, when packets come in the IP layer, they hit pre-routing. So pre-routing, we can do things like NAT them, we can mangle them, we can mark them, and a bunch of other things that modify the packet before we make decisions on it. So that's pre-routing. After that, we select packets that go to the local system. So if the destination of the packet after pre-routing is the exact IP address of the router, or other rules that let us match not exact packets, we hit the input chain. So the input chain processes packets that are going to the router itself. That doesn't mean they're going to the router to get routed. It means that the router itself is running a service that's answering this packet. So stuff like DHCP. If you do DNS on your router, it's DNS. If you do NTP on your router, it's NTP, that sort of stuff. If they don't hit that, then they go to forward. So forward is where we do a route lookup. We determine where the packet is going to go, and we look up the forwarding table. This is where the bulk of your firewall rules will go. You're saying who can talk to who. Neither of those people are the router itself, so they're forwarded packets. We also have a special case for output, that is packets generated by the router itself. Usually we just allow all of those because it's simpler. And then after all of that, we have post-routing. So in post-routing, we can again NAT packets, mangle them, do stuff based on modifying the packet. This is where SNAT comes in. So masquerade NAT, if we're pretending to be a single IPv4 client because of IPv4 legacy shit, we do that in post-routing. So up here in the INET filter, INET, by the way, means we're dealing with both v4 and v6 in one table. NetFilter used to require you to have IP tables and IP6 tables, but now we can just do the INET table. So here in the input, I've got some basic rules. So I accept everything in the backup interface just as a backup, so we're not doing a firewall there. Same with loopback. Everything established related. So this is like return traffic. Usually we just accept this right out and drop invalid. And so then for here, so stuff that we directly accept, we accept ICMP and v6. This is ping, router advertisements, neighbor discovery, that kind of stuff. On the WAN interface, so again, I'm using a variable here for WAN. This is DHCP v4 and DHCP v6. Use these UDP ports. And then on LAN, so LAN 20, fancy, we've got, again, DHCP v4, DHCP v6. And actually, we could put a group here. So if I came up here to, instead of just using LAN 20, I could define LANs as a group. And then down here, where I'm doing LANs, and maybe we'll say LAN 20 is the only one that can do SSH. So the group notation means we can have more than one of them. So on the forward chain, I've got a couple different examples here. We're always going to accept established related. This is the return traffic and drop invalid, so that's generally a good rule to have. So here I've set everyone on LAN 20, so in interface, input interface name, LAN 20, out interface name, WAN, accept. So we let everything go LAN to WAN. And I've got some basic port forwarding rules. So if you want to port forward in legacy IP, you would say came in on WAN, goes out on LAN 20, the dest address, the port, accept. So this is what is matching with a NAT rule. And same for IPv6, we can allow traffic. Here I've done this neat trick where I've masked off the first 4 words. So we're just looking at the suffix here. So we're saying if it came in on WAN, goes out on LAN 20, and the last 64 bits match this EUI64. That way, if our prefix changes, this firewall rule doesn't have to change. We're going to let them in. So these are just some example rules you can use to sort of get started. IIF name, OIF name, you can also match on an IP or IP6, DAdder, SAdder, TCP dport. There's just a whole bunch of syntax you can put in this file here. So hopefully I didn't breeze through this too fast, but I just have 2 example rules. I basically want to port forward an IPv4 legacy. So I got a mapping from port 8080 to one of my VMs that's acting as a client, port 80. And same for IPv6, we just let it through the firewall. We don't NAT it because we never NAT an IPv6. But those both go here in the forward rule. If you're doing NAT, you end up writing the rule twice. Once to actually modify the packet and once to allow the packet. So first in pre-routing, we have to DNAT the packet. So we change the destination from the local system to the internal IP. And then separately, we have to allow that through the firewall. So a lot of commercial firewalls will merge these together in one step. OpenSense will track the rules together if you let it, and they'll show up in the automatically generated rules. Here we got to write them twice, not a big deal. And then down in the NAT table, we're only doing NAT for v4, so we have an IP NAT instead of iNet NAT. So in pre-routing, this is where port forwards go. So I got this example where if it comes on WAN, going to TCP port 8080, we're going to kick it over to 10.10.20.150, port 80. So you can use this for your port forwarding needs. And then again, going out, we need masquerade. So I have, if we're going out on WAN, then we masquerade. And just to prove that it works, I'm going to curl, this is the address of the router in IPv4 on port 8080. And I get my service running in the background, which is actually just the caddy example site. So that's basically what I got for today. So I got the Mono Gateway up and running. I know you guys have been looking for videos on this ever since Tomasz started shipping it. So like I said, I was pre-order number 59, and he shipped all the US ones first because of tax reasons, so I was in the European bucket. And I did a live stream of it a little bit ago. I don't know if you guys saw that. Tomasz saw it. He jumped on the live stream. And so I installed OpenSense, did some packet testing on this, and found that the hardware offloading is actually really incredible. So this thing is powered by just a basic USB PD supply. I mean, it's not drawing that much power. You can feel how warm it is and how tiny the fan is. And it's not having a hard time doing like line rate 10 gig. I did 10 gig in that test and it was fine. So doing 1 gig today, it's just laughing at 1 gig. That's at least for the basic routing, NAT, firewall, contract stuff. So what I haven't got into testing is how the hardware offload deals with like tunnel interfaces. So I think they have hardware offloading PPPoE. I feel so bad for anyone who lives in Germany and still has to deal with that shit. Like, why? But anyway, I'm going to have tunnels to my autonomous system. So you may know I have a router in Poland, Grand Rapids, Los Angeles. Maybe someday I'll be in an Internet Exchange or peer with you guys personally or whatever. But so I need to get a tunnel from here up to Warsaw so that I can use the IP space that I have advertised there. So I'm guessing that that tunnel will not hardware offload cleanly. I looked at setting it up today, but getting the IP tunnels to punch through my CPE firewall here from the ISP is kind of a pain in the ass. So usually actually I set the OSPF timers really, really low, like just a couple of seconds between sending messages. And that's just enough to keep the firewall open. I didn't want to deal with setting up burden OSPF today, so you just get basic routing. You don't get policy routing, multi-table. All of that can be done with Network D. And my routers in Warsaw and Grand Rapids are doing all of that right now with Systemd Network D. So I started using that. I looked at Etsy Network Interfaces, which is IF up down, or IF up down BusyBox, or IF up down 2, or IF up down NG. All 4 of those implement Etsy Network Interfaces. I tried a variety of them to get my tunnel interfaces set up, hated all of them. So I ended up with systemd networkd to configure my routers. And I've been a huge fan. So I have templates in Jinja that Ansible is able to fill in all the different peer-to-peer tunnel connections, push those files to the server, reload, and it's pretty happy. So that all comes up. This guy is going to be managed the same way in Ansible once I'm done getting it configured relatively manually so that I know what the config is like. I'm going to migrate sections over one at a time to Ansible. So I'll probably start by migrating the downstream LAN interfaces so I have a template LAN, and then it can fill in sections from Netbox, what VLAN it's on, that kind of stuff, and get those populated. Then maybe I'll start writing some manual configs to do policy routing for edge cases and things like that, and eventually migrate those over to Ansible as well. That's my long-term goal. I'm sure you guys will follow along for that. Don't forget to check out boot.dev. So 25% off, link in the QR code, link in the description, all that good stuff. I also sell merch. If you're interested in my Cloud Free is the New Luxury to de-Google, de-Microsoft your life, I sell this shirt. Also the Home Lab, Your Own Personal Data Center, that's a pretty popular one. So those are at my Ko-fi, link down below for that. If you want to chat with me, Discord server is the place for that. All the configs I wrote today will be on my blog. I decided they're small enough they don't have to go on GitHub, so they're there. Also some bonuses, I have systemd resolved, so the DNS server. I did a little bit of configuration for this. The default Armbian turned off MDNS and I turned it back on. Stuff like that. So not super advanced, but that's on the blog as well. So check that out. And I guess I'll see you guys on the next adventure.